again. We have to sum to n terms this expression, and the interesting part about this is we're summing each. So this is the first term. What colour shall I use? Let's use that. So this is the first term, and then the second term, and the third term, and the fourth term, and the nth term will be that one there. And individually, you can see that each of these terms is itself the sum of a series. So we've got a sum of the sum of series. The way you'll be writing this, the way we work it out, is you use the summation symbol twice. So this sum is equal to, and we're going to use two summation symbols. If I write how it goes, and I'll show you how this works. So we're going to get the sum from r equals 1 to k of r, and then we're going to go from k equals 1 to n. Now that will, it might not look like it immediately, be the same as all this lot here. Now let me show you how that works. So this, you just ignore that first lot. What I'm now going to look at is just this expression here. I'm going to show you that this is the same as all this top row that we actually have to find. So in here we've got k varies 1, 2, 3, 4 all the way up to n, and r varies all the way up to whatever k is. So first of all, let's try when k equals 1. That is the first one. So you can think of that as having brackets there. Doing that k equals 1 first. If k equals 1, then we're going to get r goes from 1 to k, and this time so r goes from 1 to 1. So we're going to get the first one when k equals 1. We're going to get the sum of r equals 1 to 1 of r, which of course is just 1. There's no more to add on. Now, because our k goes from 1 all the way up to n, then we'll add on the next one. That's when k equals 2. If k equals 2, we get the sum from r equals 1 to 2 of r. And this is 1 plus 2. Because you put in 1, then you put in 2, and then we have to stop there because that's all we need. That's k equals 1, that's k equals 2. The next one will be when k equals 3. We can keep doing this, we must keep doing this all the way up until n, but anyway, let's do it when it's 3. We'll get the sum from r equals 1 to 3 of r. That is 1 plus 2 plus 3. And so on and so on. And you can see that the first thing we get is 1, then you get 1 plus 2, then you get 1 plus 2, 3, which is the same as we've got here. And you get the sum of the sum of series. You use this double summation expression to work it all out. That will occur when you see sums of series as terms as you're going along. Now let's actually work out what that all comes to. So this is the same as this, but now let's try and actually work it all out. We have the sum k equals 1 to n. Now we know an expression from r equals 1 to k, and that is k to k plus 1 over 2. So we already know how to evaluate that, and it is just what I've written here. Let's just expand that a little bit. I'll take the half out of all this expression, so we get half there. Then we've got the sum from k equals 1 to n. That's very bad, very, very bad k. Into k squared plus k. And we'll just expand that out. I might need a little bit more space. Come down here. I don't like red. I'm going to a different colour. That is half. Now we know, I'll do it slowly. We get the sum from k equals 1 to n k squared plus sum k equals 1 to n of k. And now we have an expression for k squared, and we have an expression for k going 1 to n each time. For k squared, we get n to n plus 1 to 2n plus 1 all over 6, and for k 1 to n we get n to n plus 1 over 2. And this will be an expression for the whole lot. So now this is an algebraic activity. We have to make this lot as simple as we can. And, well, you just got to be, you'll be careful with it. Make sure you got the same fraction. Then you're going to be carefully factorising some stuff. So here we go. Just onto the algebraic activities now. So this is going to be, I'm going to put these all as 6's on the bottom. Right, to make that 3, you have to multiply top and bottom by 3. And we get 3n to n plus 1 over 6. And now we can take the 6's out and we get a 12th. Inside the bracket we look for what's common. What's common is n into n plus 1. Left behind is 2n plus 1 and just the 3. Nearly there. 1 over 12 n to n plus 1. That's 2n plus 4. We can take a 2 out of that and we'll get 2 out of 12 into n to n plus 1 to n plus 2, which is n to n plus 1 to n plus 2 all over 6. And that will be our expression for the sum to n terms of our original thing. Now all this lot here is just some algebra. You're just being careful with making sure you've got the same denominator and then factorising out. Before this was the perhaps more conceptually difficult part. When you get the sum to n terms of a series and each individual term is itself a sum of a series, then you use the double summation expression to work it all out, and hopefully I've convinced you that that is the same as that. And then once you've got that idea, you go through the whole lot. These can be kind of tricky questions. Alright, I'll stop there.